My name is Mani, and today I'll be showing you my second milestone for my object detection project on the Raspberry Pi. So, this milestone involved one, training my own model, and two, getting a simple user interface in order to run and test the model using images uploaded from the internet or images that are taken um, apart from the. First, I gathered my dataset from the Stanford Cars dataset, which I used approximately 8,000 images from, um, and I then generated XML files, individual XML files from there using a script, and then I proceeded to use the GitHub repo from NanoNets, which is just a service that allows you to build machine learning models. Um, as you can see, I have my project open in Visual Studio, and there are different files that allow you to do different things using an API call. A challenge for this part is when I uploaded training on their website, it was really difficult to add a lot of data sets at once. So, especially when it came to the XML files, the issue was we could only upload a few at a time, and it would also cause a lot of lag because of the amount of images being processed. So instead, I wrote a simple script in my upload training file that simply allows you to go through each XML file and gather certain data like the coordinates for the bounding boxes and also the label, which for me was simply cars, and it would allow each image that was uploaded simultaneously to have annotation data. Next, you can see the script I wrote on my Raspberry Pi in order to actually test my machine learning model. Essentially, I use OpenCV in order to stream my camera onto the screen. As you can see, when I start my script, my camera runs. And then I take a picture, and each frame, essentially it counts as a picture, and I send it to the NanoNets API, and it uses my model to get a response. In that response contains the bounding boxes for which it thinks the object is in. I then proceed to use OpenCV's rectangle drawing feature and shape drawing feature in order to use those boundaries to draw a rectangle around my object. An issue with this was the extreme lag and the delay in the response times. This is mainly caused due to the slow response from the API. So streaming was extremely difficult and laggy and sometimes didn't work. So for now, I decided to simply, rather than streaming, the user would be able to upload an image, and that image would then be shown on the desktop with bounding boxes. We can see a reflection of our program's run. Although these were through multiple runs, you can see that NanoNets is detecting my model is detecting the object, which is a toy car, because as of now, I can't take my Raspberry Pi out of my room because it needs to be plugged in. So I can't test it on an actual car right now. However, as you can see, it's detecting objects, in this case a toy car. It's not 100% accurate. As you can see, it is detecting the car, but it's detecting multiple times in the same image, which isn't supposed to happen. But yeah.